Okay, well, welcome to this tutorial on Ashee. So in this tutorial, we're going to be looking at how we can add more phases into our Ashee simulation. As if you recall, the standard Ashee has one fluid phase, usually water, and two solid phases. Okay, and those solid phases have to be less than 1 millimeter in diameter. Okay, so now we're going to learn how to add multiple. Well, in this case, we'll do solid phases. Add more solid phases, but you can also add more fluid phases in the same way. Okay, we're not going to be adding Lagrangian particles. We're just going to be adding continuum phases, solid phases. Okay, so I'm going to highlight where things are different from the standard Ashee model. Otherwise, I'm going to go through fairly quickly and fairly similarly to how we did in the previous tutorial, the standard Ashee tutorial. Okay, so the first thing we need to do is navigate to the run directory of our OpenFoam folder. So you can see here I've got my terminal open. I'm just going to change directory into the OpenFoam, and then a username, which is OS boxes in my case, and then run. Okay, so now I'm here. I'm going to make a new directory or a new folder. So make dir mkdir. So I'm going to call this new directory plume test phases because it's going to be telling me that I'm adding new phases. I'm going to enter that directory. Oops. Hang on. I didn't quite get that right. There we go. So I'm in the new directory now. And so recall I need to copy some of the necessary files from the set scenarios that are set up in Ashee. So I'm just going to type copy -r because I want everything. OpenFoam Ashee tutorials. Ashee, and then set scenarios. I messed up something there, did I? Right, I missed the dot at the end. So if I come back here and press up, I can go back to my previous command, add a space, add the dot, and that'll copy everything over. Okay, so now if I list what's here, I've got this new folder set scenarios, which I'll get into here. And if I have a look what is in this folder, I have everything that I have these two folders, dat and folder 0. Dat and folder 0, and then I have these two files, cset.sh for shell file and set.py. And if you recall, set.py is one of the main things that we need to use to set up our simulation. So let's open that with get it. Okay, so as you recall, there's a whole lot of parameters here that we can change, and well, let's just run through them again. Res, recall, was the resolution of the mesh. I actually want to, sorry, that's the resolution of the mesh at the vent. So we've got, at the moment, 4 cells spanning the vent. I'm actually going to change it a little bit to, I'm just going to change it a little bit to 5. I don't want to make that too high because it'll probably slow my computer right down. But I also want to get a little bit of more information about accuracy of my simulation. Okay, Q was the mass flow rate, so it was kilograms per second. If you recall, last time we used 1.0 times 10 to the 8. I might just half that actually, so I'm going to use 5 times 10 to the 7 kilograms per second. My temperature of 1200, I'm quite happy with that. 5% of things that are exiting the vent is water. So I'll leave that as it is. And so if you recall, last time we had 2 solid phases, this coarse and this fine particle. Coarse particles and fine particle solid phases. Okay, so this is basically, this is where we want to change now, because we want to add a few more solid phases. Maybe we will add 2 more solid phases. So what I'm going to do is I'm just going to copy this line and paste it in twice, and I'm gonna come up with some new names for these solids here. So I'm gonna, let's call this solid. Well, let's go 500 for 500 microns. And then what should we call this one? Let's go solid 250 for 250 microns. Okay, so now we need to set the proportion of each of these. Okay, so at the moment 25 plus 25 plus 25 plus 75 is much greater than 1. So we need to make these add up to 1. So let's put 60% of our solid particles as being fines. Let's put 20%. Well, let's put 20% as being coarse, the most coarse particles, and then the remainder. So that gives us 20 left. So let's put 10% in each of those, the 2 new classes we've created here. Okay, so now 0.2, 0.1, 0.1, and 0.6. If you add those together, that should give you 1. So being ejected from our volcano is 5% water, of course 95% solid, and that 95% solid is made up of 20% of the coarsest, 10% of the 500 micron, 10% of the 250 micron, and 60% of the fine phase, which will set the exact particle size later. Okay, so now we've told Ashee that we want to add 2 new phases, and so we'll just move on and we'll see what else we need to change. Okay, the air is always 1 minus everything, so at the moment air is 1 minus coarse minus fine minus water. Okay, but now we've also got 2 more phases, so we actually need to have minus solid 500 and minus solid 250. Okay, so now wherever at the vent air is going to be 0, because 1 minus something that's going to add up to 1, and everywhere else air is going to be equal to 1. Okay, I'm not going to change these numbers, the heat capacities or the gas constants for air and water. So heat capacities, I'm not going to change those. Okay, densities, I do need to change the densities, right? So again, I'm just going to copy this file here. I'm going to add 2 more because I need 4 solid phases. So I've got solid 500, so let's go, let's add the 500 there, and let's go 250. So now I've got 2 more densities corresponding to the 500 micron solid phase and the 250 micron solid phase. Now let's mess around with these densities. I don't know what the right value should be, so let's make this one maybe 2000, and let's just see what happens if we reduce that to 1000. So we've got one that's quite a light phase in terms of its density. Okay, so we've added some mass fraction of two new solid phases, and those 2 new solid phases now we've given a density. Okay, we'll leave the densities of the coarse and the fine phases, coarsest and the finest phases alone. We're going to leave this pressure alone. So this, if you recall, is basically the atmospheric pressure at altitude z equals 0, or the altitude of the vent. But if you recall, one thing we did need to change was this pressure, right? Oh, what happened there? This pressure is the pressure at the vent basically exiting the ground, okay? So it's kind of like the choked, or some kind of choke condition. And if we recall last time, to calculate this pressure, we had to open a new file, right? So what I'm going to do is open a new terminal, and well, where is it here? Okay, if I cd back to my home directory, then if you recall, I have this file called mac.py which we had to use to calculate the pressure at the vent. So what I'm going to do is I'm going to open that. Okay, so it's opened up over here, and recall that I need to match these numbers between these simulations, right? So my mass flow rate was 5 times 10 to the 7. Okay, 5 times 10 to the 7. Temperature was 1200. Water mass fraction was 5%, but now you see I need to add in these extra ones here. So I can do that quite easily, just copy and paste, right? And recall my course was 20%, my fine was 60%, everything else was 10%. Okay, so I'll just tab, oops, what am I doing here? Let's go, that's good. Okay, so this was 20%, this was 10%, and this was 60%. Okay, and now of course air, we have to subtract our other two phases too, so that we know the mass fraction of air. 250. We need to keep these gas constants and these specific heats constant. But I think they are, right? 287, 462, 717, 1348, and 1100. Okay, so they're good. But we do need to set the density of our two new phases too. So I'm going to copy that from here and paste that in here. Okay, so now I've added in my two extra densities of my two extra phases here. The atmospheric pressure is the same. Okay, so now we're almost ready to run, but we need to remember that, okay, well, we've added in two phases here, so wherever we calculate something with solid phases down here, we're going to have to make some modifications. So here, this is the mixture gas constant for the fluid phases, so water and air. We don't need to change that at all. This is the inverse density of the solid phases, so this is where we're going to have to make some modifications. So you see here we have the fine zero, so that is the mass fraction of the fine phase. We have the density of the fine phase, and then similarly mass fraction of the coarse phase and the density of the fine phase. So we have to now add in the mass fraction of our new phases divided by the density of our new phases. HR HO 500. Okay, so I'm just going to copy that and make this was the 250. Okay, so now I've added in the mass fraction of the 500 micron phase divided by the density of the 500 micron phase, and then similarly for the 250 micron phase. So now we shouldn't have to change much else, or at least nothing in this part. Okay, good. I don't know why this is 0 here, so maybe we might have to actually comment that out. So there seems to be a 0 there that shouldn't be there. Okay, and then okay, so then the next set of parameters we might need to change. Rho V, so well, this automatically is calculated from this mixture density which we calculated here. So because we've changed this line up here, we don't have to change this line here. CVM, so this is the mixture heat capacity, so we do have to change this line. So we have the water heat capacity here, the air heat capacity here, and then the solid heat capacity here. So here we've got the fine and the coarse phase. Of course, we need to add in two other phases. So solid 500, solid 250. Good. So then this is calculated from the mixture parameters, which already include these new new solid phases, so we don't change this line or this line. And just checking, this line looks good too. Okay, so I think we've calculated everything that we need. So what I can do now is save that and then run mac.py. So if I again got to choose my desired Mac number, let's do 0.75 again, and of course I've crashed it. Okay, so I see the problem is that when I copied it over from the previous file, we had this little bit here that we didn't actually need. We only need the numbers, not this. Well, this is basically making it a vector. So what I'm going to do is I'm going to just delete these parts here, and that should make it happy again. Let's see. Similarly, in the density. Okay, so if I save that and then try running mac.py again, I'll just give us a clear 0.75. Okay, we get this new, it's actually not too much different from the last time, we get this new value of the pressure at the vent. So I'm going to just take that as it is. I'll go back to my set.py and use that in my pressure. Here we go. Good, so I'm actually going to change the next two lines. So my mesh radius, well, I might actually up that to 40 kilometers, so now I've got an 80 kilometer domain. And my mesh height, I'm going to change that to 40 kilometers because last time we hit the top of that domain. So by reducing the mass flow rate and increasing the mesh height, I should be able to avoid that problem of the eruption leaving the top of the domain. Okay, I'm going to leave all these things as they are. The number of processes to run this on, I'm going to leave that at 5 because I've got I think an 8-core CPU, so I want to use 5 of them. Okay, and last time that was all we did. We didn't change anything else. But there is one more thing that we need to change now. If I keep scrolling down here, there's a lot of code that can look quite confusing at times, but we don't need to change any of this until we get further down here. Okay, so you probably recognize this from my mac.py code. So this is actually calculating now the Mac number for the code. So what we need to do is now add in our extra phases. So if I go back to mac.py, I'm just going to copy this bit and add that in there. So now the solid density is taking into account the finest particles, the coarsest particles, our 500 micron particles, so we've got the mass fraction divided by the density, and then the 250 micron particles. Okay. Again, this line does not change because we have the solid density including our two new phases. This line here does not change either, rho V, so because rho S already accounts for our two new phases. But again, the mixture CV, the mixture heat capacity, we do need to account. We do need to add our new solid phases in here. So let's go plus solid 500 plus solid 250, and now we've added so that now our heat capacity will be, our mixture heat capacity will be correct. Gamma is good, UV is good, everything else looks good to me. So I think we can save that now and move on to our, everything below here is just mesh things that we don't want to mess with just yet. But now we can save this and move on to video 2. Okay, I'm going to close this and then move on to video 2.